Hello, Heron and Riverside students. We're going to continue on with the energy unit, so make sure to keep taking notes under the energy unit, and specifically today is 5.4, all about the forms of energy. Some of this may be review from previous science classes you've maybe taken in middle school, but still make sure to take good notes so that you're prepared for your quiz and future tests. So there are a few types of energy. We're going to start with mechanical energy. So this is the sum of the potential and kinetic energy. So gravitational and elastic potential energy and kinetic energy. So we see some examples here, whether it might be like a roller coaster or cars moving around a racetrack. An equation we can think of is total energy or mechanical energy equals K, kinetic energy, plus U, potential energy. And an object has mechanical energy because of its motion or position. So make sure to take notes on this. The next type we're going to talk about is thermal energy, and you could probably guess it, but it is energy due to the motion of particles. Atoms and molecules are constantly in motion. They have kinetic energy because they are in motion, and that is energy in motion. And so kinetic energy of particles increase as temperatures increase. So maybe you've seen graphics, or we'll look at some in class, that the faster energy is moving or particles are moving, the more kinetic energy there is, the more thermal energy there is when it's hotter. So if you're boiling water, those particles are moving very fast versus ice cubes in the freezer. Although the particles are still moving, they're going much slower because of the thermal energy in them. So we're not going to watch the simulation today, but you'll watch it in class. Our next type is chemical energy, and chemical energy is the energy stored in the bonds of molecules. Me personally, this is my favorite type of energy to explore, and it is both the formation of bonds and the breaking of bonds, and that requires energy. So we can do different things to chemicals to create, to see this energy exchange. So here is actually a lighter, lighting on fire and changing. So an example of chemical energy would be lighting a match. Or digestion is another common type of chemical energy. Next is electrical energy, and it is the electricity that results from the flow of charged particles through wires or other conducting materials. So this, pretty straightforward. If you think of electricity, that you need electrical energy for electricity. And then these charged particles have kinetic energy. So we would see the flow of electrons throughout here, and that allows electricity to form. So that's like electrical energy. And of course, since the electricity is moving, that's a type of kinetic energy. So this graphic is a little bit showing you how electricity gets to your home, and there's all this transfer of energy. So we have electricity is generated at the power plant here, then it goes through, it moves, so kinetic energy, to this power box that you see all around. Voltage is increased at the transformer station, then it moves somewhere else through the wires, and you've probably seen, these big wires, and then electricity travels across the province on transmission lines, and then the neighborhood transformer station decreases voltage, so it goes down again, and then it's carried to your neighborhood, and then lights your house, and if your dog's lucky, it lights your doghouse too. So that's just kind of showing the flow of electricity throughout the wires. Next, we also have electromagnetic energy, and this is the idea of light can carry energy across an empty space. So these are electromagnetic spectrums. The electromagnetic waves carry the light energy from the sun to the earth. They all travel at the speed of light, and the speed of light is 3.00 times 10 to the 8th meters per second. And later on in the semester, we'll talk more about this number and the speed of light. But right now, what's important is the idea of this electromagnetic spectrum. We have something as large as a radio wave and as small as like an X-ray or a gamma ray. And X-rays and gamma rays have a lot of frequency versus these other that have a larger frequency. And then we also have our electromagnetic light spectrum, so red, orange, yellow, green, blue, violet colors as well. So make sure you've taken notes on all of these forms of energy so far. If you need to, you can review any parts up until now. And then other examples, like I said, of the electromagnetic energy would be visible light energy. Like I said, it can be separated into Roy G. Biv. Red has the lowest energy and violet has the highest energy. And think about, why do you think most laser pointers would be red? Think about it and then answer the question on the Edpuzzle. And then we can we'll be looking at different examples in class. The next form of energy is sound energy. Sound is related to energy because it causes vibrations of particles. And we can see this through liquid, solid, and gas. And vibration is motion. Thus, this is a form or type of kinetic energy. So you've probably heard of sound energy or things that you hear go in waves. And we see that. And then next we have nuclear energy. And this is kind of a more broader spectrum that we don't see quite as often. However, the sun's energy does come from specifically nuclear fusion. And nuclear fusion is a type of reaction in which light atoms or particles combine to form heavier particles. So if we think of two things fusing together, we have one thing and another thing coming together, thus it's fusing together. So in this case, in nuclear fusion, we have atomic particles combining with other particles to form something heavier. So that's nuclear fusion. And then also part of nuclear fusion or nuclear energy is nuclear fission, the opposite of that, where heavier particles split apart. So if you've heard of like fission or different, like you could have a fission type fracture, and that is when your bone is splitting, and this is splitting to form lighter particles. And in both fission and fusion, a small amount of mass is converted to energy in each atom. So that's where we can talk about the energy transferring from one thing to another. And these small amounts over millions and billions of years and more atoms produce very large amounts of energy that we see. So here is an example of fission. So we have one big molecule splitting into smaller molecules, or uranium splitting into like krypton and barium, for example. Again, splitting is fission. And then fusion, we have two atoms coming together, fusing together. So we see that animation as well. And nuclear energy, like we said, the sun uses nuclear energy through fusion. Fusion requires extreme temperatures and pressures to occur, and that's why the sun you can think of as being so dangerous. It has so much pressure and so much temperature because of that nuclear fusion. And that is it. So make sure you have paused the video throughout, taken notes on each of these different forms of energy. If you need to, review these and make sure you're ready for the next class. I would even recommend making some note cards with the form of energy on one side and the definition or examples on the other, so you can help study for your quiz and then the test you'll have coming up as well. If you have any questions, feel free to email your teacher. Also, we'll review this content next class. Have a wonderful day.